Hey, what's up everyone? Vegetarian Zombie here again, and I want to welcome you back to my Beginning C# with Unity series. In this episode, I'm going to be covering C# types, but before we dive into that, let's talk about your last assignment. To do this, I'm going to switch over to MonoDevelop. As you can see, I have Unity already open, and here's where we last left off. I asked you to create two new variables, another game and a star rating. And I wanted you to make them accessible within the inspector. To do this, I'm going to create two new variables. And the first one, I'm going to call this another game name. You can see I set it to public, and for the type, I use string. Now for the name, I'm going to put another, and now I'll capitalize G, game, and then I'll capitalize N, name. And this way, it can be clear from a distance what this variable is. I'm going to call this, let's say, Minecraft. As you can see, we have our quotation mark before I put in my text, and then after my text, I put a close quotation mark. And to conclude this statement, I use the semicolon like so. And let's give this a rating. To give this a rating, I'm going to give it the public accessor. I'm going to give it an int, and I'll just give it the name rating like so. With a number, we don't need to use quotation marks. I'll just put 5. And then to end this off, I'll close off with a semicolon. So another game name, Minecraft, rating is 5. Once this is set, I'm going to save this, and then I'm going to build this. I don't necessarily have to build this. It just sometimes saves me a step or two. I'm going to switch over to Unity, and with the cube selected, we can see now our two fields are there, Minecraft and 5. I can say give this Half-Life 2 or Half-Life 3. Maybe that's part of me subconsciously channeling Half-Life 3. And I'll give this a 4, like so. And of course, to access this, let's add a method for onEnable. To do this, I'm going to type void and then onEnable like so, exactly. Then open parentheses and close parentheses. After which I'm going to put an open brace, and then I'll type in debug.log. And I'll just write out a simple sentence. The game, and then I'll put a space, and then a close quotation mark, and then use the plus sign because I'm adding this name into this sentence. Or you can think of it like this. I'm taking this string and I'm adding it to this string. And the result is going to be a combined string. Another game name. Now we have the game plus another game name is rated at, and then I'll close this and put another plus sign, and I'll add the rating like so. Then I'll add another plus, quotation marks, stars, period. And now that I'm complete, I'll put my close quotation mark followed by a parentheses and then the semicolon. This close parentheses is balancing this open parentheses over here. And then I will close this method out. As you can see, we have an open brace, so we have to have a closing brace. I'm going to save it, and I'm going to build it. And now I'll switch back to Unity. Everything should work. Let's run our game. And you can see the game Half-Life 2 is rated at 4 stars. In this video, we're going to be covering types. And you've already been exposed to a couple types. And those types are string and int. I'll be introducing you to other types, and I'll be going into a little bit of detail about how these types work. This is important when you're assigning values to these types because you may run into some adverse effects. And we're going to go a little deep into this lesson, and this is going to be somewhat more of a lecture base than a demonstrative base, but it's incredibly important you understand these concepts. Okay, let's take it from the top. As I mentioned, I introduced you to the string and to the int. We actually have some more to cover about the int, so it's a very good place to start. Just to recap, an int stands for integer, and this is a whole number. An integer has what is known as a range. And this is important because you always must stay within this range. If you put a number outside a given range, then what happens is you'll get some unexpected behavior. Well, what do I mean when I'm talking about ranges? Well, to understand this, we have to dive a little deeper. And basically, we have to see the way the computer sees. And this is one of the few times we're going to go a somewhat low level. But believe me, this is very understandable. And once you understand it, it's like seeing the Matrix. You can't unsee it. Okay, let's think about this. How does a computer store data? When we assign a variable the number, say 5, how does the computer store that 5? Well, the computer works in bits, and a bit is simply a 0 and a 1. By combining these bits into a sequence, the computer can then determine a value. Now let's take a look at a sequence of bits. We're just going to use a byte. What is a byte? A byte is just 8 bits put together. So let's look at it right here. Here we see 8 zeros. Can you guess what number this represents? That's right, this represents 0. Now let's count. I'm going to increase 1 bit on the far right to 1. This indicates the number is 1. Now I'm going to indicate the number 2. As you can see, the second bit is now set to 1 and the first bit to 0. That is 2. Let's see 3. And let's see 4. And here's 5. And here's 6. The computer keeps track of this. You don't need to. So why is this important to know? Well, we're working now with a byte, which, as I mentioned, is 8 bits. And if we had a number that was the size of 1 byte, you can see right here that 8 bits will represent all the numbers that variable can hold. Meaning this byte can only hold a value of negative 128 to 127. You cannot go higher or lower than those ranges because there are not enough bits, there are not enough zeros to represent those larger numbers. But what happens if you do try to do that? What happens if you try to set a value to say 128 on this number? Can you guess? Well, in C#, we have something known as an overflow error, meaning the value of 1 will be added to 127, and since there are not enough bits to represent that number, you then go into the negative numbers. Those additional overflows will be added to the negatives, and that will be your number. This is not a desired behavior. What would happen is your program would enter an unstable state. It had bad data put into it, and then you'll get some really strange reactions from it. Now let's take a look back at this byte again. As you can see, we have our byte representation of 127 and then negative 128. So how does the computer know if a number is positive or negative? Well, it determines that from the far leftmost bit. If that bit is 0, then the number is positive. If the bit is 1, then the number is negative. But there are going to be times when you're not going to want to work with negative numbers. And you could use that extra bit for data, for more data. By doing that, you increase the size of the number. This is where we have an idea known as unsigned types, meaning that leftmost bit to indicate the sign is instead used to increase the value of the number. We call these unsigned types. So in this case, we're working with 8 bits, which is a byte. And when we're working with signs, the range of the number can be negative 128 to 127. If we decide to discard that signing bit and use it instead to increase the value, the range of that byte goes from 0 to 255. This number, as I mentioned, we worked with is called a byte, which is 8 bits. But you can have other numbers of increasing size. The int itself is actually 4 bytes, meaning it contains 32 individual bits. And as you can see, the range of this integer goes from negative 2 billion to positive 2 billion. But if you decide to drop the sign off the integer, then you can go up to 4 billion. Most of the time, you're going to be working with just the type. You're just going to be working with an int. But if you ever needed to use the unsigned version of int, you'd put a u in front of it. Instead of calling it int, you would call it uint. Here's a list of number types that you may use. So the first item is called assigned byte. This is what we were just using. Typically, when working with bytes, you think of them from 0 and upwards. You don't think of them in negative. So they kind of flipped things around in C#. Here you have the signed byte, which is known as an S byte in code. So if you use this, you would type S byte and then the variable name. And this is 1 byte, and you can see the range of values. Or you can use a byte. And again, the size is 1 byte and goes from 0 to 255. Next, we have a short integer. And this is a type of short, as you can see here. And it has 2 bytes. And so it can range from negative 32,768 to 32,767. If you want to use the unsigned short integer, you would put u short. And again, this is 2 bytes, but now you go from 0 to 6,535. You've seen the integer, and you've also been introduced to the unsigned integer. If you need to go larger than the integer or the unsigned integer, you can use the long integer. And this integer is 8 bytes. You'd use the type long to indicate you were going to use that. The long integer also has an unsigned long integer, and this is known as ulong. And again, this is 8 bytes, and as you can see, the range is pretty extensive. If you needed to even go larger, such as if you're working with an engineering application or a scientific application, you can use the decimal data type. The type is called decimal, and it's 16 bytes. You don't need to use a decimal point in it. And as you can see, it's a very, very big number. What happens if you take an integer and divide it by another integer? Let's say we had the number 5 and we want to divide it by 2. Can you guess what the result would be? Yes, this is a trick question. It's going to be 2. Integers do not contain any data relating to decimal points and so forth. These are just whole numbers. What happens is when you divide 2 by 5, 2 can go into 5 twice, and then the remainder is simply discarded. This may seem odd, but this is working with integers. Again, if you don't need to have the overhead of having a decimal point and floating point values, then working with integers, it's perfect. It works great for a lot of things. But there's going to be times where you're going to need floating points. The first decimal point you'll be using is the float. And this is a number that has 4 bytes. And as you can see, these are the values that it can contain. Floats have a relatively low number of precision, meaning the numbers after the decimal points. Because computers have a finite amount of memory, what happens is the precision of those decimal points are lost. There's no way, for instance, for a computer to have all the values of pi stored within it. It's an infinite number, and computers just could not do that. You'd need infinite amount of memory. Because of that, floating points in computers tend to be imprecise. In terms of working with scientific applications and engineering applications, it could be a problem. But when working with games, we don't have to worry about it. Games are a lot like cooking. We can get away with fudging a bit. This isn't true with, say, working with astronomy. Say, for instance, you're calculating trajectories based off star charts and so forth. The loss of precision could result in a craft flying millions or billions of miles off target. But again, we don't have to worry about these things. Most of the time when working with Unity and in C#, you'll be working with floats. And primarily, floats are fast. But if you need to have greater precision, you can use what is known as a double. And this is double the precision of a float. It's a type double, and it takes 8 bytes. And as you can see, the range is pretty extensive. This is the default value in C#. When you type in your editor 1.1, the compiler will see that and will assume that is a double. This will give you a large amount of precision. If you want to use floats, you have to cast the value of the double down to the float. What casting means is you're taking a double, which is twice the amount of precision and twice the amount of data, and converting it to a float, which is half that amount. What happens is you're going to lose data. For a number like 1.1, that's not going to matter at all, but for a larger decimal point number, that's going to have some implications. In such a way, you have to explicitly say, I am casting down to a float. I choose to lose precision. And you do that by putting a lowercase f after the value. That's kind of like one of those things where you're online and you're deleting your character and it says, type delete to continue, and you type in your name to continue. That's what that F is. That F is making you say, okay, I'm choosing to use a lower precise number, and that's okay. Unity uses floats all over the place, so you'll be doing this a lot. When you forget to do this cast, Unity will give you a cryptic error informing you that it doesn't take a double or something along those lines. You'll be seeing this error throughout this course, but don't worry about it. It's a common error, and once you'll see it, you'll notice it right away from then on. There's a few other types we have as well. I've introduced you to the string, and believe it or not, the string can hold up to 2 billion characters, so don't worry about running out of space there. And we also have a date time type, and generally speaking, you probably won't be working with date times a lot. Next, we have a character, and this will represent a Unicode character, and this is of 2 bytes. Another important type is the Boolean type, and this is of type bool. It takes two bytes, and the values are true and false. In just a few episodes, you'll see why this type is so important, and you'll be using it a lot. The final types that you can use are object, class, and structures. I won't be covering these now, as they're a little more advanced at what we're doing, but down the road, we will be covering these in detail. They all tie into object-oriented programming, which we'll be covering extensively in this series. Okay, I'm going to switch back to MonoDevelop now. And let's check out some of our types. First, I'm going to create a byte, and I just do this by typing byte, and I'm going to give this the name Overflow Error. For a value, since I'm going to create an overflow error, I'm going to call this 256. Let's see what happens. As you can see, constant value 256 cannot be converted to a byte. Right now, the compiler is catching this number for me. What if I turned it to 255? We'll build, and you can see here, it just gives me the warning, I'm not using this number. Okay, let's see this in action if we increment this overflow error past its range. To do this, I'm going to give you a sneak preview at operators, and I'll be covering this in the next video. Here, I'll type overflow error, and then I'm going to add 1 to it. What this is doing is adding 1 to the overflow error and then assigning it back to the variable of overflow error. Unfortunately, this is going to create an error in itself, and this has everything to do with casting, which you'll learn in the next video. But for now, I'm going to convert the results of this addition into a byte. Remember how I talked about adding the F to a number to indicate that number is a float instead of the double? That's what I'm doing here. I'm indicating that the result of this addition is not an integer, but a byte. Now let's print out the result. And here I'll put plus overflow error like you saw. And then instead of putting a plus or anything like that, I'm just going to put a closed parentheses like so. Now let's go back to Unity and see the result of this. Here, I'll stop this. Now we'll run it again. And now we'll disable. In this case, the result is 0 because we had 255. Let's see what the result would be if this is a signed byte. Remember, a signed byte is known as S byte. And because of this, we have to turn the number down to 127. Here, I'll build again. And this is telling me I can't use a byte, so I'm going to switch this to an S byte instead. Now let's switch back to Unity. And now we'll disable our cube. And you can see the value is -128. You can play around with all the different numbers, but it's really important for you to understand how floats work. To create a float, I'm going to type public float, and I'll call this my float. And we'll give it a number of 1.2 like this. And then I'll save here. Right away, the compiler is giving me an error. It's telling me literal of type double cannot be implicitly converted to type float. As I mentioned, what is happening here is the compiler defaults to all decimal values to a type of double. We're trying to use a type of float. So we're losing precision. To get around this, we can use F, like so. Now we'll save and build, and the number goes away. Likewise, you can use this parentheses float like you've seen below. And this will do the same thing. This converts, by putting this in parentheses and float, this converts this number to a float. Although typically you'll see it written like this. And now if we switch back to Unity, we'll see my float right down here. Working with bools is relatively easy. I'm going to create a new public variable, and I'm going to assign it bool. And then I'll just give this the name likes game, and I'll assign it the value of false, just like that. And then I'll build, and I'll switch over to Unity. And you can see back down in our inspector, we have likes game, and you can see now that we have a checkbox to indicate whether it's true or false. Checks indicate true, whereas empty checkboxes indicate false. And with that, you've been introduced to the world of types. For the most part, you're going to be using integers, floats, booleans, and strings. The other types are at your disposal to use for certain situations, and you may know when to use those when those situations arrive, such as parsing data coming from a socket or parsing files and so forth. But we're not going to dive into any of that. Typically, a good strategy is just use an int whenever you need to use a number. If you find the value of the number going too high, then you can increase. You can say use a long integer instead. You may be wondering when to use unsigned integers or unsigned shorts and so forth. Again, just stay with the int until you need to change, or if you're working with a team, they may have specific instructions on what types to use. But for now, just focus on the basics. Work with the basic types, and the other types are available if you need to use them. Okay, before I sign off, I have to give you your next assignment. In this assignment, I want you to create some Mad Libs. I want you to create a string that has your name, another string indicating your favorite food. Next, I want you to have an integer for how much of that favorite food you like to have. And to make things fun, make it an unsigned integer because you like to have lots of it. And then use a Boolean value, whether you like to share it. Your Mad Lib's going to go something like this. Start off by saying my name is, and then put the variable for your name, and my favorite food is, and then put your favorite food variable. Then write, and I like to eat it, then put the amount you like to eat, the unsigned integer, followed by times a day. And I like to share it with others. And then at the end, put a colon followed by the Boolean value. Okay, well that's it for this video. As you can see, it was pretty heavy on theory and a little light on demonstration. That's typically going to be the next few videos, I think, but once we start getting in control flow, things are going to get a lot more interesting. You can think of it now as you're really setting up the scene to make some really cool stuff down the road. But for now, we got to do the grunt work. If you have any questions or concerns or so forth, definitely leave me a comment. Or if there's something I might have missed, definitely raise your hand and let me know. Thanks again for watching this series, and hopefully you've been learning a bunch of stuff, and I look forward to covering operators in the next episode. So, see you then.